Hello and welcome back. This video will take confidence intervals or information about confidence intervals and reverse engineer some information about them. So remember that a confidence interval is going to be a range of values for which we are confident a population parameter is going to exist in. In this section, we're looking at population proportions. So we would be some percent confident that the population proportion will lie between the sample population plus a little bit and minus a little bit, plus the margin of error and minus the margin of error. So one nice thing is that if you were given the confidence interval, we can figure out what the population proportion was and what the margin of error was. So if we think about it in this way, we have a range of values that will make up our confidence interval, and we'll have p hat plus e plus our margin of error, and we'll have p hat minus e. The nice thing about this confidence interval is that it's symmetric, and p hat is going to be right in the middle. If L is going to be if L is going to be the lower bound of our confidence interval, and U for upper bound of the confidence interval, how do we find the exact middle? Well, we just take the mean of the two values. We add U and L together and divide by 2, which should give us the midpoint, the exact center. Also, the margin of error is going to be the distance from the midpoint to the edge, or in other words, it's going to be half the distance from the lower endpoint to the upper endpoint. So if you take the difference and divide it by 2, this is just going to be the margin of error. So this we can just go through a quick example. So let's say that we were given a 95% confidence interval, and it's referring to the proportion of people who successfully stop smoking using some method, maybe a patch, and we're told that this confidence interval is from 58% to 81%. So we just want to estimate, well, what was the actual sample proportion that they found, and what was the margin of error here? Well, p hat is going to be the exact midpoint of our confidence interval. So p hat is just going to be 81. I'll do this in decimals. So 0.81 minus 0.58. Plus 0.58 divided by 2. So it's going to be exactly in between. So it's going to be the average, the mean of the two endpoints. Which, if we add these together, this will be 1.339, and dividing this by 2 will give us 0.695. So the sample proportion would have been 69.5%, 0.695, whereas the margin of error is going to be half of the length of the confidence interval. So we just need to find the length of the confidence interval, which will be 0.81 minus 0.58, and we'll divide that by 2. So when we subtract these, we'll get 0.23. Let's do this in my head a little bit. 0.23, and this is going to be 0.115. So our margin of error was 11.5%, which seems quite big. So maybe there's only a small sample. Okay, so my final comment was about well, the margin of error depends on the sample size. So if we want a smaller margin of error, we have to take a bigger sample. So one question is, if I know how big I want my confidence interval to be, how many people would I have to go sample? How many objects would I have to go sample to try to come up with a margin of error that's pretty small? And the answer is, well, we can just use the formula for the margin of error and solve for n. So if I take this equation and I manipulate it until I get n by itself, we get this. So the size of a sample that you need to get a particular margin of error E is going to be the critical score, the z-score squared, times p hat times q hat, all divided by E squared, the margin of error squared. So again, the smaller the margin of error, the smaller number I'm dividing by, the bigger n is going to have to be. Now, one thing here is that in order to express how confident we want to be, we've got to know our the percent confidence. So we know if we want to be 90% confident or 95% confident. This tells us z. And E here is the margin of error, which we want to be small, so we'll pick a value for how big the margin of error is. But this assumes that we know P and Q. So P here, P hat, is the proportion in the sample that satisfies the criterion. So this already assumes that we know the percentage in our sample. But if we don't know how big of a sample we haven't taken the sample yet. So this right here, this p hat, we can either estimate a value for p hat, which we think is going to be close. So we sort of guess, and then we go out and we'll calculate how big of a sample we would need based on that guess. Or, worst case scenario, if we don't have any idea what p hat is, we can always use 0.25 instead of p hat times q hat. 0.25 is essentially the biggest possible value, so we're hedging our bets so that we'll just take a big enough sample size. So let's apply these formulas. So in order to construct a 90% confidence interval with a margin of error of 5 percentage points, how many people would need to be surveyed? Okay. So again, we're wanting to calculate how big of a sample size we would need here. So we want to calculate n. We will need our critical value. We will need our p hat and q hat if we can assume what they are, and we need the margin of error. So we'll assume that p hat will be 75% first. So we'll assume that 75% of people will say agree with the question on the survey. So here, our critical value for a 90% confidence interval is 1.645, slightly smaller than say a 95%, because we're just less confident, so we can have a smaller interval. So we'll square this. P hat will be 0.75. Q hat, which would be the people that don't agree with the question on the survey, or would be counted as a failure. The complement of 0.75 would be 0.25. And our margin of error will be 5 percentage points. And we have to be careful, because 5 is not correct. It's 5 percentage points, meaning that it'll be 0.05, as in 5%, 0.05. And if we run through this, we'll get 202.95. So this is how big of a sample we would need to take for people of people being surveyed to have a confidence interval, a 90% confidence interval that has a margin of error of 5. Now, 202.95 people, that doesn't really make sense, so we would want to round that to the next larger whole number. So this would be our sample size that we would need to survey. Now, if we can't assume that 75% of people will agree with the survey, or at least close to 75%, we should hedge our bets and make sure that we pick a large enough sample so that we can have our confidence interval be the right size. So in order to hedge our bets, we pick 0.25 for this, which will always be larger than p hat times q hat. And here, essentially nothing changes, except that instead of having 0.75 and 0.25, we just put 0.25 there, as in that matches. And then E is again going to be 5 percentage points, so 0.05. And for this one, we get 270.6. So if we're assuming that we're surveying people, I can't survey 0.6 of a person, so we would want 2.71. So again, if we know a little bit about the population and we were able to guess what our p hat should be, we don't need as big of a survey. But if we have no information and we still want to create a confidence interval that is a particular size, we'll just have to survey more people. And by surveying more people, we can guarantee that our confidence interval is as small as we want it to be.